Second part of that theorem, our unique factorization theorem, is uniqueness. So suppose there is a polynomial no, let's not call it f of x. Suppose there exists a polynomial that does not factor. Uniquely. So suppose there's a counterexample to our uniqueness claim. Then of all the counterexamples, there must be one with the smallest degree. So let's let a of x be the polynomial, the smallest degree, or a polynomial smallest degree. There may be more than one of the same degree, of course, with this property. So that means we can write a of x as a product of irreducibles. We already have existence, but in two different ways. So these two factorizations are supposed to be factorizations into irreducible polynomials. And they're supposed to be distinct. They're supposed to be different. So what we notice is, so P1 of x divides Q1 of x up to Qs of x. And remember we had that result that if a prime divides a product, then it divides one of the factors. That was for a product of two things. So you can sort of group it this way if you like. So now it's a product of two things. So P of 1 of x either divides Q1 of x or it divides this thing. And if it divides this thing, then you again break it up into a product of two and it divides one or the other. And so on until you get that P1 of x divides Qi of x for some I. But these are both irreducible elements, so the only factors are units and associates. So P1 of x is an associate of Qi of x. So P1 of x is, say, equal to U Qi of x. But then let's factor this P1 of x and this Qi of x out from both sides. We can do that because, recall, f of x is an integral domain. So we can cancel P1 of x equals U Qi of x from both sides. To get, say, P2 of x up to PR of x is equal to Q1 of x, Qs of x, where the Qi is missing. And there's also this U inverse, because I factored a U Qi out of it, that I'll just group together with that one to make this our new irreducible polynomial. Multiplying by a unit doesn't change that it's irreducible. This gives us this new polynomial, b of x. So b of x has the same property, the same non-uniqueness. So we found a new polynomial with the same property, but the degree of b is strictly less than, because we've canceled out this p1, the degree of a. And that's a contradiction. Thus, no such A of x exists. And factorization is unique. And we're done. Okay, so we'll see you all on Monday. Bye.